Hello, everyone, and happy Wednesday. As you know, I am out of school today, and so you are going to be doing the intro to chapter 4. I know it says chapter 6. I just didn't edit that part of the paper, but you are going to be using chapter 4, and we are going to be starting a concept called solving systems of linear equations. So last unit we talked about graphing them. This time we're going to be talking about solving systems of equations. So just jumping right into this, I am gonna move this because I don't like looking at myself and it makes a weird glitch when I touch the screen if I don't move it. So what do points on the graph of a linear equation represent? So what do each of these points represent? So we have a point here, we have a point here, we have a point there. Pretend that's on the line, but we have all these little points and they're all xy's. What do they represent? So we have xy. So if we chose this first one, right there on the y-axis, that is up 1, 2, 3, 4. So that is 0, comma 4. That 0, 4, if we were to plug that into our y equals 2x plus 4, this is our x and this is our y. So that would be 4 equals 2 times 0 plus 4. 2 times 0 is 0, so 4 equals 4. So what it is a solution to that equation. So all the points on the graph represent a solution to the equation. So if we have one equation with two variables, how many possible solutions xy are there? How many possible xy's do we have in the problem right above? Well, I already labeled 5 or 6. So yes, there would be infinitely many. Many solutions, which are x comma y. All right, now, what if there were two equations we were looking at? How many solutions for xy are there for y equals 2x plus 4? That is, not that one. That is this one. I'm going to erase this line. How many solutions are there for that line? Right, infinitely many. And then if we wanted to look at the other line, how many solutions are there for y equals negative 3x minus 1? That's going to be this line right here. How many points can you grab out? How many xy's can you grab off of that line? If that line is going to go on for forever in either direction, it is also going to be infinitely many. All right. And how many solutions do xy do they share? So how many of the same xy points do they share together? If we were to pull a bunch of those xy points off of that graph. Well, to see that, we'll have to see what they have in common. They have in common, that is so off. Right there. That point. So they have that one point in common, which means that they share one solution. So this is what we're going to be doing for this chapter, figuring out what point two equations share or the solution to a system of equations. So you're going to hear it a few ways. It's either the point they share, the solution to the system of equations, or the point of intersection. All three of those statements mean the same thing. So solution to the system of equation and the point of intersection mean the same thing. Those are the two you're going to hear most common. So a system of equations we can define as, let me make sure I give you the right actual definition. In layman's terms, we can define it as 2 seconds, guys. Sorry. Two or more equations that share variables. So a system of equation is two or more equations that share variables. And as y'all know, I'm not great at spelling, so if I misspell something, sorry about that. And then a solution to the system of equations. That is their shared xy coordinate. So I'm going to write that in one term, in one color, since it's just in layman's terms. So they're shared xy. And in more exact terms, we are going to say the values for the variables. I'm going to zoom in real quick. The values for the variables that are simultaneously true, that are simultaneously true for the equations. So the values for the variables that are simultaneously true for the equations. For solutions of linear equations, we're going to come across three different types or situations that we might have. You can have two linear equations. So the first one we're going to have is if we had a line like this and a line like that. When you look at these, you know that one has a negative slope, and then that green one has a positive slope. So you know they have different slopes at the very least, because one's negative and one's positive. So you can say that this is one solution because they intersect one time. And then you can put a little note. They have different slopes. Okay. Now, our second situation would be one that you had this line right here. And then if you drew one parallel to that, so line going in the same direction, parallel to it. So parallel means are two lines that will never touch or cross because they are going at the same rate at the same slope. So those are parallel. So what that means is when we're looking for solutions to a set of linear equations, we're looking for that point of intersection. We're looking for that x, y they have in common. These are never going to have a point of intersection, so this would be a no solution. Then we will have our third situation. And I'm going to draw this. An 8 is a bit excessive. A 4 will be fine. We have that pink right there. And then we'll go with our green. Right on top, we can pretend it's exactly on top. I'm just not that great at lining it up. So what these are is how many points do they have in common? They have every single point in common. These are the same function. So this would be a situation where you have infinitely many. On the no solution, their slopes are going to be the same. So go ahead and make that note. Slopes are equal. That's very messy, sorry, but it says slopes are equal. But what's different is where they might intersect that y-axis. So the top equation, which I think I'm going to change to a different color just so we can see it a little easier. See that they are two different equations. that top equation is going to intersect the y-axis at about 4, and that bottom equation intersects the y-axis about 3.5. They have the same slope, but different y-intercepts. And on the infinitely many, they have the same slope and the same y-intercept. So everything about the equation is the same. For no solution, the slopes are the same, but other things are different. And for one solution, both the slope and the y-intercept are different. So let's go ahead and look at these. The first thing I'm going to say is we are asking the question, do the following systems have one, none, or infinitely many solutions? So we just talked about the things that make it have one, none, or infinitely many solutions. So that's the slope and the y-intercept. We're trying to see if that equation is the same. So looking at this, I'm going to start off with my slope. My slope on this first one is 2. My slope on the second one is -3/2. Are those the same? No. So you can say that this will have one solution, which will be your answer, and it's based on the fact that they have different slopes. If you have different slopes, you are going to be rising at a different rate than the other one, and so you are going to intersect at some point. On our second one, first thing we need is for this to be in y equals simplest terms. So I'm going to simplify these equations. So first I'm going to simplify by distributing this 3 to both the 2x and the 4. So that becomes y equals 6x plus 3, 6, 9, 12, 12. And then I'm going to solve for y equals on this bottom one. I'm going to add 6x to both sides. Keep in mind that -3 and that 6 do not combine because one of them has an x and one of them does not. So that will become y equals 6x minus 3. All right. So we're trying to see how many solutions we have. So the first thing we look at is our slope. Our slope in our first one is 6. Our slope in our second one is 6. They have the same slope. Let's double check their y-intercepts. Y-intercepts. Our y-intercept on our first one is 12. And our y-intercept on our second one is -3. Look right above. How many solutions do they have when they have the same slope but different y-intercepts? They are going to have no solution. That's going to be your answer here. No solution. Because they have the same slope but different y-intercepts. So they would intercept the y-axis at different times, but still be going up at the same rate as the other one. And so they would never they would never cross. They would be parallel lines. All right. How many solutions does this have? We can't do anything until this is in simplest terms. So that's the first thing we are going to do is simplify. So we are going to distribute that 2 to the x and to the -2. So y equals 2x minus 2 times 2 is 4. And then on this bottom one, first thing I'm going to do is combine like terms. We have 2 x terms. So now we have -3y equals -8 plus 2x is -6x plus 12. Now we need to solve for y. We are going to solve for y by dividing everything by -3. This one cancels out. We end up with y equals -6 over -3. How many times does 3 go into 6? Twice. A negative over negative is a positive. So 2x. How many times does 3 go into 12? 3, 6, 9, 12. 4. A positive over a negative is a negative, so -4. So y equals 2x minus 4. Y equals 2x minus 4. What do we have here? We have the same equation with the same slope and y-intercept, meaning they have how many solutions? Infinitely many. All right. Now moving on to our next page. Go ahead and pause the video here. When you finish these problems, you should be working them by yourself. When you finish them, then you can check your answers on my video. So pause video here. All right, you should be unpaused now and you should be checking your answers. All three of these problems should already be done. Remember, the only practice you get is in class practice. So on this first one, we need to combine like terms. We get y equals negative 2x minus 14. We need to distribute that negative 7 to both terms. Y equals negative 7x minus 14. Do they have the same slope? Nope. So you can say one solution. Putting this first equation into y equals terms, we're going to subtract that 3x across, divide everything by 4. We end up with y equals negative 3 over 4x plus 4. Do these have the same slope? Negative 3/4x and negative 3. Nope. So you can say one solution. All right, third problem. First, simplest terms. I'm going to take this. I'm going to add 5x to the right, divide everything by 10. We will end up with y equals 5 over 10x, which is just 1 over 2x, plus 10 over 10, which is just plus 1. So, same slope, different y intercepts. That means they have no solution. Good. They will never intersect. These are parallel lines. No solution. All right. So we had one solution, no solution. All right. Let's focus on systems where we know have one solution. Slopes are different. We can check ordered pairs in the solution of systems by substitution. Check that to see if the point is a solution to the given systems. So we know we have one solution in these systems. They already tell us that. All we are doing is checking to see if that point is a solution. I want you to follow the steps that I do here so that you don't make any mistakes. So, the first thing I do anytime I am checking a point to see if it is a solution, I'm going to go x, y, and then label these 1 and 2. It says to check this by using substitution. What does substitution mean? It means to substitute something. So if you are substituting something, you have an xy point. You're going to substitute that for the x and the y's in your equations on 1 and 2. So starting off with 1, I am going to first write my equation with no x and y's, and in place of my x and y's, I'm going to put parentheses. What I mean by that is I'm going to say open parentheses because there's an x on that first equation, close parenthesis, plus 2 times open parenthesis, close parenthesis equals 6. I wrote my equation with my x and y replaced with parentheses. Now I'm going to fill in the number that I have for x and y. So my x was 4 and my y was 1. 2 times 1 is just 2, so we have 4 plus 2 equals 6. 4 plus 2 is 6. 6 equals 6. That is true. You're going to put a check mark. Now that you did it on 1, you can do it on 2. Write your equation without your x and y in just parentheses. So parenthesis, parenthesis, minus parenthesis, parenthesis equals 3. My equation without my x and y's with just parentheses. Replacing my x and my y. 4 and 1. 4 minus 1 is 3. 3 equals 3. That is true. It wants the question it is asking is check to see if this point is a solution. If they both are equal to each other like that and they both check out, then yes, it is an answer. And that is your main answer. On a quiz, I want to see your work checking this point and then your answer, yes. So it will be a two-part answer, it would be your work saying, plugging in your answer, and then yes or no saying whether it worked. On the second one, I'm going to follow the same steps. I'm going to do it in a different color so we don't get confused. So x, y, 1, and 2. Starting off with our first equation 1, writing it without our variables. We're going to do parenthesis, parenthesis equals 2 times parenthesis, parenthesis plus 8. Our y was negative 2. Our x was negative 5. Make sure you are placing the correct number in the correct variable. Do not mix those up. All right. 2 times negative 5 is, good, negative 10. So negative 2 equals negative 10 plus 8. Negative 10 plus 8 is negative 2. So negative 2 equals negative 2. That checks out. Problem number 2. Write it without parentheses. Y equals, what I forget? My negative sign. Yep, negative, parentheses, x, parentheses, plus 3. Good. Replace your x and y. Your y was negative 2. Your x was negative 5. Negative 2 equals negative minus a negative 5. Negative and negative together make a positive, so that's just going to be 5 plus 3. 5 plus 3 is 8, so we have negative 2 equals 8. Is that true? That's where you're going to put an x, and then you're going to say no. Anytime you get something that is not true and that you have to put an x, you can stop at that point. You have proved that it is not a solution because it is not a solution to one of them, and you can say no. So if we would have solved the first problem, the second problem first, and would have found out that it didn't work, you could have stopped at that point, said no, and circled your answer. Now I want you to look at these 3 problems. Do them on your own. Pause the video here. Okay, you should be done with these 3 problems and just checking your work. So let's go ahead and substitute in. Remember, we follow the same steps every single time. So we are going to do x, y, 1, 2. Substituting for 1 first, we have y equals 2 times x plus 1. Replacing our x and y, we have 3 equals 2 times 1 plus 1. 3 equals 2 plus 1. 3 equals 3. That checks out. For our second one, we have y equals 4 times x minus 1. Y is 3. X is 1. 3 equals 4 minus 1. 4 minus 1 is 3. 3 equals 3. Checks out. They both check out, so we have a yes. Remember, I've been looking for that yes, and I'm looking for your work. Again, I'm going to change colors in the middle. X, Y, 1, 2. 1. Y equals 5 times x minus 1. 9 equals 5 times 2 minus 1. 9 equals 10 minus 1. 10 minus 1, 9 equals 9. Checks out. 2. 2 times y minus 3 times x equals 12. 2 times, I'm just going to fill in my bubbles real quick. 2 times 9 equals 3 times 2. So 2 times 9 is 18. 3 times 2 is 6 equals 12. 18 minus 6 is 12 equals 12. Checks out. Yes. Last problem on this page. So we have x, y, 1, 2, 1, 3 times x plus 2 equals 2 times y. 3 times x is negative 2. Y is negative 4. 3 times negative 2 is negative 6 plus 2 equals 2 times negative 4 is negative 8. Negative 6 plus 2 is negative 4 equals negative 8. Since that one doesn't work out, you can say x. No, you did not have to solve the other problem if you solved this one first. So that is your answer on those three. Next, we are going to talk about solving systems by graphing. So go ahead and grab a graphing calculator. If you don't have a graphing calculator, I'll provide some resources. Give me 2 seconds. Okay, so I've tried to get the calculator emulator to work on this Screencastify, which is what I'm using to record this, but I can't get the emulator to pull up as a website on here. So what we are going to do is we are going to work on these problems at the very beginning of next class. So what you need to do is make sure you are prepared for the quiz next class. So what's going to be covered is anything on these first 3 pages of notes. So you need to make sure that you understand this material, practice the problems again. You can go ahead and resolve them even if you've already solved them. That's great practice. And you're going to go make sure you understand this material because you will be having a quiz next time you come to class. Thank you for doing the work while I am gone. And please email me with any questions or concerns you may have.